fundamental group. So, kind of start out.
Matthew.
So this is the water solubility data. We have 72 highly correlated predictors. Those big blocks are highly correlated blocks of variables. And then kind of the squares you see are square root of 72 predictors chosen that are kind of correlated together. So this is not a good correlation structure for a regression problem because one of our assumptions is that our variables are uncorrelated, and obviously there's a fraction of correlation here. So what we did was we decided to use BCAs. So we chose to use 33 principal components, and that basically eliminated every single, all of the correlation structure in our data set, which helps us not violate the independence assumption. So we fit a crap ton of models. So here's kind of our misclassification and our AUC rates. None of them were particularly great. Kind of the best ones that we have here were our SVM and our KNN and our random forest. And that naive Bayes sucks because all of our predictors were numeric, and naive Bayes really likes to see factor predictors, specifically binary predictors, because that's kind of the assumption that the internal model makes. And surprisingly, ElasticNet and RDA were really, really close to each other, and logistic as well. So all three of these predictors, we were wondering maybe there's some sort of correlation between that. So that's what we decided to look at. We decided to look at all the correlation between predictors.
LDA and logistic regression are numerically equivalent.
Oh.
They're the same thing, basically.
Okay.
Yep.
So we looked at our correlation structure and we saw this. So naive Bayes, being the weirdo that it is completely, well, it's not uncorrelated, but it's negatively correlated with most of the things. KNN also, oddly enough, is super separated from everything else. And all the other variables are kind of in just one giant block, even though we can kind of see 3 blocks here. Just the way that I implemented core plot just only draws 3 boxes because it draws square root of n. So I decided, okay, let's eliminate some of these poor predictors and ensemble. So I eliminated ElasticNet and naive Bayes. So I eliminated this row because it was just such a poor predictor. I didn't want it influencing my results and saying like, hey, like, this is actually an insoluble compound when it's like table salt, right? That's obviously soluble. And then I also eliminated ElasticNet because of the correlation structure I see here, because all of these were my good predictors. So if I remove this one, it's going to eliminate a lot of this correlation structure. And I didn't really care about what's going on down here because, who cares? So I ensembled and I got a really damn good misclassification rate. So what I did was I did an ensemble using SVM. So basically I chose my best model and I modeled my models with my model so I could model what I modeled. So that's kind of how ensembling worked in our case. We use a support recognition just with basically default settings.
Okay.
Just scroll.
Yeah, I'm just gonna
Click and scroll. Did it not? Oh, the
Here,
mouse
there.
went over to the other page. There we go.
Okay. So I was looking at the Alzheimer's data, the problem number 2. And again, there's a correlation structure. I chose to ignore that because after I made the PCs and tried to model those, I wasn't getting any better predictions than I was just regular data. So I just kind of dropped that idea and used just the original data, the 132 predictors. I don't know.
Move it over to the other screen.
Oh, that's it.
Yeah.
So I tried a bunch of different models and a bunch of different things and fiddled with this and fiddled with that. Basically came down to the SVM model. I was getting a misclass rate for the validation data of 12%, and I'm like, well, that's the best I was getting because all the others are around like 20%. So I'm like, 12 is good. Yeah.
So yeah, after this, we're renaming our group again. We're now the support vector Martians because SVM just kills everything.
Yeah.
And in the spirit of this class, we have an entire slide of bad jokes. So why don't statisticians like to model new clothes? Because there's a lack of fit. Yeah, no, that was the third one specifically for you.
Yes.
That's the word.
Transform away.
Wait, you mean you tried something other than a lock transform? What are you even doing? And then